Let's take a look at why the derivative of sine of 2x is not simply cosine of 2x. Here, we have to think a little about the meaning of the 2 in 2x. For the basic sine of x function, the period is 2 pi. The 2 in 2x means the basic period gets divided by 2 to make a period of just pi. This means the graph of sine of 2x is compressed relative to the graph of sine of x. This causes the graph of sine of 2x to be steeper. Look at these little slope triangles. These measure the average rate of change. Notice the horizontal change, delta x, is the same for both of them. If we take the triangles out of the graph and compare them, we see they have the same delta x, but the green triangle, from sine of 2x, has a bigger vertical change. This confirms that sine of 2x is steeper. Recall, perhaps from your Calc 1 class, that the y-coordinate of the derivative is the steepness of the original function at a given x. For example, at x equals 1, y equals 2 on the graph of 2x, which is the derivative of x squared. Notice now that if we compute the average rate of change around x equals 0 using sine of 2x, we get a vertical change of about 0.4, a horizontal change of 0.2, and the ratio is 2. Here, because the hypotenuse of our average slope triangle matches the curve so well, we pretty much know the value of the derivative at x equals 0 is 2. Now, if we simply use cosine of 2x as the derivative of sine of 2x, at x equals 0 the value of cosine of 2x is 1, which is not 2. But the value of 2 cosine of 2x at x equals 0 is 2, matching our calculation. This relationship holds across the graphs. Please be sure to like and subscribe. Your simple 1 millisecond click really makes a huge difference.